Mars, the red planet, has always been a source of fascination and speculation. For centuries, we have wondered about its potential to harbor life and its mysterious history. Over the last few decades, our exploration of Mars has revealed a world that was once very different from the barren, rocky desert we see today. Mars was once a planet where water flowed freely, carving out riverbeds, filling lakes, and perhaps even forming vast oceans. But as we look at Mars today, the water that once existed on its surface seems to have vanished, leaving behind a cold, dry landscape. Yet recent discoveries suggest that Mars may still hold vast reserves of water, hidden deep beneath its surface. This water is not easily accessible. It is buried kilometers below the Martian crust, well beyond our current technological reach. This revelation opens up a host of new questions and possibilities, not only about the history of Mars, but also about its future potential to support human exploration and even life. The watery past of Mars. To understand the significance of Mars's hidden water, we must first journey back in time to when the planet was young and vibrant. Billions of years ago, during the Noachian period, Mars was a warm and wet world. The planet's atmosphere was much thicker than it is today, capable of trapping heat and supporting a hydrological cycle similar to Earth's. Evidence from Mars rovers and orbiters suggests that during this time, water flowed across the planet's surface in rivers and streams, creating a network of channels and valleys. These rivers likely fed into large lakes and possibly even seas or oceans. One of the most striking pieces of evidence for Mars's watery past is the presence of ancient river deltas and sedimentary rock formations, which can only form in the presence of standing or flowing water. For example, the Jezero crater, where NASA's Perseverance rover is currently exploring, was once the site of a large lake, fed by a river that carved a delta into the crater floor. The rocks and minerals found in this region suggest that water was present for long periods, providing the necessary conditions for life to potentially develop. However, this wet and warm environment did not last forever. Around 3.8 billion years ago, Mars began to change. The planet's magnetic field, which had protected its atmosphere from the solar wind, weakened and eventually disappeared. Without this protective shield, the solar wind, a stream of charged particles from the sun, began to strip away Mars's atmosphere. Over time, as the atmosphere thinned, Mars became colder and drier. The water on its surface either evaporated into space or froze, becoming trapped in the ground as ice. Mars's disappearing water. Theories and discoveries. The question of what happened to Mars's water has puzzled scientists for decades. The most widely accepted theory is that the loss of Mars's magnetic field allowed the solar wind to gradually erode the atmosphere, causing the surface water to evaporate and escape into space. This process would have taken millions of years, slowly transforming Mars from a warm, wet world into the frozen desert we see today. However, not all of Mars's water was lost. Some of it became trapped underground, where it has remained hidden for billions of years. Recent research has provided new insights into where this water might be and how much of it still exists. In a groundbreaking study published in the Proceedings of the National Academy of Sciences, PNAS, scientists have identified what could be a massive reservoir of liquid water deep beneath Mars's surface. This research, led by Vashon Wright of UC San Diego's Scripps Institution of Oceanography, analyzed seismic data collected by NASA's InSight lander to explore the structure of Mars's crust and identify the presence of water. InSight, which landed on Mars in 2018, was equipped with a highly sensitive seismometer known as SEIS, Seismic Experiment for Interior Structure. This instrument was designed to detect Marsquakes, small, naturally occurring seismic events similar to earthquakes on Earth, as well as the impacts of meteorites. By studying the way seismic waves travel through the planet, scientists can gain valuable information about the composition and structure of Mars' interior. Seismic waves behave differently depending on the materials they pass through. For example, certain types of waves travel more slowly through liquid than through solid rock. By analyzing the speed and direction of these waves, scientists can infer the presence of liquids, such as water, beneath the surface. The data collected by SEIS suggests that there may be significant amounts of liquid water trapped in the mid-crust of Mars, between 11 and 20 kilometers below the surface. The discovery of potentially vast reservoirs of liquid water beneath Mars' surface is both exciting and challenging. If confirmed, this water could represent a significant resource for future human explorers. Water is essential for life as we know it, and finding it on Mars would greatly enhance the feasibility of long-term human missions to the planet. Water can be used for drinking, growing food, and even generating oxygen and fuel through electrolysis. However, accessing this water is a monumental challenge. Drilling down to depths of 11 to 20 kilometers is beyond our current technological capabilities, even on Earth. The deepest hole ever drilled by humans, the Kola super deep borehole in Russia, reached a depth of about 12 kilometers, and it took over 2 decades to achieve. Drilling on Mars with its harsh environment and logistical challenges would be even more difficult. But the presence of this water, if confirmed, also raises intriguing questions about the possibility of life on Mars. On Earth, we have discovered life in some of the most extreme environments imaginable, from the deep ocean trenches to the hot springs of Yellowstone, and even kilometers beneath the Earth's surface. These extremophils, organisms that thrive in extreme conditions, have shown us that life can exist in places we once thought impossible. Could similar forms of life exist on Mars, deep underground in these hidden water reservoirs? While the conditions on Mars are harsh, with freezing temperatures, high radiation levels, and a lack of oxygen, life as we know it requires only 3 things: liquid water, a source of energy, and essential nutrients. If liquid water exists beneath the surface of Mars, it's possible that microbial life could have taken hold there billions of years ago and survived in these isolated pockets, protected from the harsh conditions on the surface. Exploring Mars' past, present, and future missions. Our exploration of Mars has come a long way since the first flybys and orbiters of the 1960s and 70s. Over the past few decades, a series of increasingly sophisticated missions have been sent to Mars, each one building on the discoveries of the last. From the early Viking landers, which conducted the first experiments searching for life on Mars, to the more recent rovers like Curiosity and Perseverance, our understanding of Mars has grown exponentially. The discovery of ancient riverbeds, sedimentary rocks, and minerals that form in the presence of water has provided compelling evidence that Mars was once a very different planet. The identification of subsurface ice deposits, and now, potentially, liquid water trapped deep underground, adds a new dimension to our understanding of the Red Planet. The InSight mission has been particularly groundbreaking, not only for its discovery of potential liquid water, but also for its detailed study of Mars' interior. By measuring Marsquakes and analyzing seismic data, InSight has provided the first real glimpse into the planet's core, mantle, and crust. This information is crucial for understanding how Mars evolved and how it compares to Earth and other rocky planets in our solar system. Looking ahead, future missions to Mars will continue to build on these discoveries. NASA's Perseverance rover, which landed in Jezero Crater in 2021, is currently exploring an ancient river delta, searching for signs of past life. Equipped with advanced instruments, including a drill that can collect rock samples, Perseverance is designed to look for organic molecules and other biosignatures that could indicate the presence of ancient microbial life. One of the most ambitious aspects of the Perseverance mission is its role in the Mars Sample Return Program. Over the next decade, NASA and the European Space Agency, ESA, plan to send a series of missions to Mars to collect the samples that Perseverance is gathering and return them to Earth for detailed analysis. This will be the first time that material from Mars is brought back to our planet, and it could provide definitive evidence of whether life ever existed on Mars. In addition to robotic missions, the possibility of human exploration of Mars is becoming more tangible. NASA's Artemis program, which aims to return humans to the Moon by the mid-2020s, is seen as a stepping stone for human missions to Mars in the 2030s. The technologies and capabilities developed for lunar exploration will be crucial for the more challenging and distant journey to Mars. The discovery of subsurface water on Mars could play a critical role in these future missions. If water can be accessed and utilized, it would reduce the need to transport large quantities of water from Earth, making long-term human exploration and even settlement more feasible. Water is not only essential for life, but can also be used to produce rocket fuel through the process of electrolysis, splitting water into hydrogen and oxygen. This could enable astronauts to produce their own fuel for the return trip to Earth, making Mars missions more sustainable and cost-effective. The future of Mars. Exploration. Questions and possibilities. The discovery of hidden water on Mars opens up a world of possibilities, but it also raises many questions. How much water is really there, and in what form? Is it liquid water or ice? How deep is it buried, and what would it take to access it? Could this water support microbial life? And if so, what does that mean for our understanding of life in the universe? These are questions that scientists will continue to explore in the coming years. As new missions to Mars are planned and launched, the search for water and for life on Mars is part of a broader effort to understand the origins and evolution of life in our solar system. By studying Mars, we learn not only about the planet itself, but also about the potential for life on other planets and moons, both within our solar system and beyond. The discovery of water on Mars also has implications for the search for life on other planets. If life can exist in the extreme conditions of Mars, it suggests that life could potentially exist in other harsh environments, such as the icy moons of Jupiter and Saturn, where subsurface oceans are thought to exist beneath thick layers of ice. In recent years, the search for exoplanets, planets orbiting stars outside our solar system, has revealed thousands of potential new worlds, some of which may have conditions suitable for life. The discovery of water on Mars adds to the growing body of evidence that water, and potentially life, may be more common in the universe than we once thought. As we continue to explore Mars and other planets, we are likely to encounter new challenges and surprises. The search for life on Mars is a journey of discovery that is far from over. Each new mission, each new piece of data, brings us closer to answering some of the most profound questions we can ask. Are we alone in the universe? And if not, what does that mean for us here on Earth? Conclusion: Mars and the quest for knowledge. Mars has always been a beacon for those who seek to explore the unknown. From the ancient astronomers who first observed its red glow in the night sky, to the scientists and engineers who are designing the next generation of Mars missions, our fascination with the red planet has only grown over time. The discovery of hidden water on Mars is a testament to the power of human curiosity and ingenuity. It shows us that even in the most unlikely places, there is always more to learn, more to discover. As we continue to explore Mars, we are not just searching for water or life, we are searching for our own place in the universe. The story of Mars is a story of exploration, of pushing the boundaries of what we know and what we are capable of. It is a story of hope, of the belief that one day we may set foot on this distant world and uncover its secrets firsthand. So as we look to the future, let us remember that the journey to Mars is not just about science or technology. It is about the human spirit, the desire to explore, to understand, and to discover. Mars may be a cold and distant world, but it is also a world that holds the promise of new knowledge, new challenges, and new adventures. And who knows, one day, the discovery of water on Mars may be seen as the first step in a journey that takes us beyond our own planet, to the stars, and beyond.